Hello, today we're going to talk about what it takes to be an actual triangle. And we know that it has three sides, three angles, but we're going to explore the relationship between the sides and between the angles. We've gone through the triangle sum theorem, but we want to kind of solidify some of the branches off of these theorems that and definitions that we know. So the first challenge says can any three sides form a triangle? And so you're really focused on the can and especially any, meaning that I pick any random numbers and will they end up being a triangle. So any three numbers like 3, 2, and 4. Will that be a triangle? You could also have something like, 5, 8, and 13. Will that be a triangle? Great question. Or even like, I don't know, my favorite number 23, my birth date 6, 10. Well, those numbers end up being a triangle if we were to combine lengths. And so for me, what I'd like to do in front of you guys is just a little experiment here with some stirs, coffee stirs. And what I have here are 3 coffee stirs. They're all of equal length. And hopefully you can see that if I have 3 of these put together of equal length, I can get a triangle. So really the question becomes, like, what happens, say, if I were to cut these? And so in front of you, you take this, you cut it. So I already know, like, if I hadn't cut this coffee stirs were manufactured so that they're the same length. And the question is, can I get a triangle from that? And so as I put these points together, and I try to, like, rotate them down until they meet at a point, what you should end up noticing is that almost there, right there is when they finally touch. And so do I have an actual triangle? And the realization of it is no. So this example is kind of like this one that says 5, 8, and 13, because the 2 segment lengths equal the last one. And that didn't work out for a triangle. We could also, like, have a little bit shorter segment. So we'll just cut this off, and then we cut these down. And the question is, will this end up being a triangle for us? And same thing, I kind of rotate them down, trying to keep them pinched off at a point. And what I realize is, well, in this scenario, I'm short. I can't actually get that vertice, so this does not work. And so can any 3 side lengths form a triangle? No, it cannot. And it's based on this ability to kind of eventually coincide at a point. If you have exactly the same, this ends up just looking like 2 lines on top of each other. This scenario, you end up with a gap. Okay, and so this is the only scenario that works out to our favor. And if I had a 3 and a 4 and a 2, would I be able to get a triangle? And so you're more looking at like this scenario. And it doesn't have to come up off the segment a lot. It just has to come up off a little bit where they can finally intersect at a vertice. Okay, so how do we write that up? The sum of the shorter 2 sides must be greater than the longest side. Okay, so that's a really important result for us. We call this the triangle inequality. And what that does for us is it provides the information we need to be able to form a triangle. The sum of the shorter two sides is greater than the longest sides to form any triangle. Okay, so this might have been somewhat intuitive to you, but maybe it wasn't. So this is the result. If you hear the word triangle inequality, this is exactly what the person is talking about. Okay. The next set of problems deals with the angles. And it says, what are the conditions that determine a triangle? Now, we already know the triangle sum theorem. So what we're really kind of starting to think about are what are the potential values that could make a triangle and exactly why they don't work. So this is more of an illustration as to why they won't work. And so it says choose measurements for A and B such that the sum of the measurements is greater than 180. Now we know we need to have 180, but why would it not work if we had something greater than 180? And let's just look. So let's pick some numbers. I don't know, something like 100, and we won't even make it close to 180. Let's make it 95. So if I come down here and I put my protractor on there and I make an angle of 100 degrees, so that's kind of over here, and I make the other angle 95 degrees, so 10, 20, 30, 40, 95 is up here. What I'll notice is there's no way for me to bring the angles back towards each other, so I can't have two obtuse angles because it breaks the triangle sum theorem, but like visually you can see how they won't intersect. Okay, choose measurements, well, where they're supplementary or sum to 180. Well, what happens if I pick two values that sum to 180? So if I had two right angles, this is sometimes a question that you have to deal with. What would it look like if I had two right angles in my triangle? Or is it even possible? And so I'll make one right angle here, and I'll make one right angle over here. And similar to the two obtuse angles, I'll notice that it didn't work out here either because they went straight up and there's no way for them to come back down and intersect. So we've dealt with obtuse angles. You might be wondering, well, what happens if I pick something like 100 up here, but instead not 95, but 75? So at least I get an acute angle. That wouldn't get us over 180. So we'll try like 110. 110 plus 75, that'll work. And I'll change the colors here so that we can tell what I'm working with. But here's 110 degree angle, and then here's 75 degree angle. And you see that it almost looks like it makes a parallelogram, but if you extend these out forever and ever and ever, further and further, you can kind of see how they won't intersect like a triangle. Okay, they'll kind of always end up being more open at the top than they are at the bottom, and we're not talking about intersecting down below. Okay, so that's an important result also. Now, how they might test you on this is something like here. Which of the following sets of angle measurements determines a triangle? Well, if I know that it's supposed to sum to 180 degrees. If they only give me two of the numbers, 30 and 120, I know I can figure out the third one. So the third angle here would have been 30 degrees. 125 and 155, that's 180 degrees already, which means that there's 0 degrees in my third angle. Well, that doesn't make any sense, so this is not going to be a triangle. This sums to 185, and we just saw automatically if we have something that sums over 180 degrees, you end up with a scenario that looks like this, where it's really open at the top, closed at the bottom. This is 179 degrees, and so although it's not much, your final degree would be 1, and this is a triangle. And finally, this 180 automatically, not a triangle. You're just going to end up getting them to the point where they're parallel to each other. Okay, so some important results. The triangle sum theorem, really beneficial in analyzing triangles. You must know that all three angles must sum to 180 degrees, and all three angles must be greater than 0. That's an important piece and part of that. And then you have the triangle inequality, which is where we know that the sum of any two sides must be greater than the third in all cases. So if you look, 2 and 4 add up greater than 3, 3 and 2 add up greater than 4, and 3 and 4 end up adding greater than 2. Specifically, you're going to see it stated like this: the sum of the shorter two sides must always be greater than the longest side to form any triangle. Okay, thank you for your time.